Okay. Whoops, forgot this part. Where is it? There it is. There we go. One note about this, I don't bother labeling surface groups anymore, just because it's a pain to do in Gmesh. So I normally just export um, all the meshes I need without actually labeling anything. I just label them as separate mesh files in here. And the next one. Wait, there we go. Let's see. Need to add the throat adapter. Which is in the ath folder. I think it's this one. Yeah. Okay, so we need the compression driver and horn type piece. Yep. And close. Interior, exterior, and interface. I think that's it. Oops. There we go. Add the horn mesh. onto this one. Yep. And um, yeah, the aft piece. Just call it throat adapter. Whoops. Nope, that's not right. Oh well. Oh, oops. Get the scaling wrong. I guess it just needs to be that. Yeah, okay. And then rotate it. And not so long. The Z-axis, maybe? Yes, just 180. There we go. Nice. And now the compression driver. I'm not going to use the full model of the DCX 464 just yet because that does add sim time. And I just want to get like a rough model in it first. And make sure that's driven. Perfect. Okay. Now we need the interface. Wait, is that tiny again? Yes. Gotta fix the scaling. And need to rotate that 180. There we go. Now we'll actually set up the solving. And I don't expect this profile to work at all, but I do want to make sure that we get the model set up at least. All right, and now we'll set up the actual observations for what we're measuring. And this actually needs to be offset for the length of the horn, which is what's that distance? 486 millimeters. So we go to position. That didn't do it. And neither did that. Okay, that's fine. Hmm. Okay, that's where it needs to be, but I need this arc to be further out. Oh, okay, it's units again, I guess. That's fine. All right, that looks all good. Yep, and close and duplicate that for the vertical. Actually, I just realized this is symmetrical. The vertical won't tell us anything different. Let's set up a 45. That might be helpful. So I guess need to rotate like this. Yeah, okay. Yep. And let's see, fixed driving enabled. I think that's it. I always wonder if I have this set up right. Nope, forgot the infinite baffle. I can't remember if that's supposed to be interior or exterior, but we'll figure it out. Needs to be like that. And then needs to come out 486.1. There we go. Now the horn is in the wall. I think that's it. Let's see what happens. All right. And while that churns, I'm going to flip back over to here. Main goal tonight is not to get like this finalized or anything, but just get the model set up. Oh, that's new. Huh. I've never seen that peak before. Guess I'll find out what that means. But yeah, to get like a kind of sort of somewhat parametric model for the setup, check fitment of things, just kind of start on the general layout of how this build's going to go together. So we'll actually start kind of modeling the horn a bit, and then we can always come back to this point in the timeline to actually like get what we need out of back if we need to regenerate those meshes. Let's see. So I guess the first thing is figuring out how the trapezoid part's going to work and what angle that needs to be at. I'm going to actually look at it like this. So let's get the back of the cabinet. That's 80. Yeah, probably like 100's fine for clearance to the compression driver. And then like the next important part is figuring out how far that needs to extend. So that's 112.6. I think what we need it to be is that. Yeah, I might have to think about that a little more. Well, let's see if this is, yeah, because I want to make sure there's room for the compression driver in the back. So that's kind of the thing that I'm kind of wondering here is if I can't get that angle exactly 55 degrees, what does it really need to be? Because in theory, you want a bit of overlap between the two, but not too much. Because you can either have an instance where the two patterns of the two speakers that are going to be coupled together will either destructively cause comb filtering, or you're just going to end up with a null in the middle. So we kind of want to ride right between that line. Um, and the directivity is supposed to be 55 degrees. So we have to figure out, does this need to be 57 degrees? Does it need to be, 52 degrees or any variation like that? Um, my gut kind of says it needs to be a little bit closer in, but that's why we're doing this part. So really what I would like to do is figure out a way to get this model set up with two cabinets. I wanted to get at least one good sim result first, but the idea is we can actually set two up at an angle and then slowly adjust that angle between them and use both driving elements to figure out what that pattern looks like in theory. I've not done this yet in Acrobac, so it may or may not work. The pink mesh is very interesting though. Let me see what I did in the draft one. There we go. So with this one, that's 109.6. So um, that's 19.6 times 2. Let's see here. Yeah, that's something like that, which like might be fine. I guess one kind of variable I have to tweak here is the length of that secondary flare piece, because if you think about like driver access and how this is all got to fit together, if I move that in or out, I can move the outside edge of that cabinet and adjust the angle pretty easily while still having room to access drivers. So I might actually have to move it in considerably. Again, kind of depends on how this shakes out here. Because really I'm trying to figure out like what the angle of the outside edge of the cabinet should be, and then that'll drive a lot of decisions around how I'm going to fit the drivers in there, which I don't feel like is going to be a challenge. These are like 29-inch or 700 millimeter wide mounts, and using the 12s in there, I mean, I can push them up if I need to, but there should be plenty of room in this inside this cabinet. There you go. Okay. Yeah, so I'm just going to roughly sketch this out and then know that I'll come back and actually change that to what it needs to be later. So that's 711. We'll go and set that, then add. I mean, I guess half inch. That's another thing. This cabinet's a little bit larger, so it might make more sense to use 18 millimeter plywood throughout, but I kind of want to see what it looks like with half inch. All right, and oops. No, I need you to go there. There you go. Okay. Yeah, like that. Okay, this is not filled in because that. There we go. Yeah, I mean, in theory, this all kind of fits together. So I guess like looking at where the constraints are, I have two areas to push and pull from to adjust this angle. One is adjusting the flare size here, and the other is pulling in or out from the compression driver, but I have very little kind of wiggle room to go in this regard. But I do just want to go ahead and set up some parameters so I can do that easily. So we'll do the S2 from horn resp, and that needs to be 16478. S3. And S4. All right, so I did that so that I can go into the actual sketches here and replace these values. Oh, shoot. That's not right. Okay, why don't you like this? Okay, maybe I need to actually remove the units. Oh, yeah, of course that works. Yep, and the sketch. Cool. So what that allows me to do now is if I need to change the angle of this outer wall, which I definitely will, um, all I have to do is flip back over to the Synergy Calc spreadsheet, which I'm still working on automating, and then change, I believe, this value, maybe? No, that's not right. Might actually be better just to kind of eyeball it. So like, instead of 50, I go like 45. Yeah, okay, cool. So that's doing the thing. Um, and yeah, this is something where too I can like go in to Acrobat and actually simulate what that does, just like I did with the version 2 of the wide variant. But yeah, that looks like it should. I do want to make it so the sketch actually moves too. That math is it this? Yeah, it's that. Okay, sick. So now I change this value. Perfect. Cool. Okay. Now I think I want to do this axis, which is going to be a lot easier because all we have to do is do that. Wait, I think I messed up. All right, just need to think about how this is set up. I guess that's right. Yeah, this is hurting my brain a little bit. That needs to be plus 12 minus 12. Okay. And then same for this one. Yep. And that can go all the way out and then get split. Yeah. Okay. Cool. See if this is, I mean, it's still going. I have a strong feeling it's gonna like give me some weird error though, because it really doesn't seem like that pink should be there. Okay. Um, what next? Driver's fit. Yeah, that's like perfect. There's like a lot of extra volume in here. Um, it's like, could I fit 15s? Probably. It's a bit excessive though. Have to think about that. Anyways, as far as getting this in here, that can go like that. That can go like that, I think. Uh, yeah, yep, okay. I think what we need to do here, oh wait, that's gonna be tricky. I think the easy way to do this is first split it, remove that. That's gonna be a really tricky angle to cut. Maybe not terrible. Yeah, 34 isn't like crazy on a table saw. It's just annoying. Uh, and then for that bottom part there, trying to think what that angle would actually be. So that's 13.8. I'd rather write a formula in here for figuring out what that angle is rather than just like sticking a value in there. Actually, it may not matter. Yeah, I can just do this. And then you go away. And then cool. I think same for this one. Oops, there we go. Oh, wait. I totally put that on the wrong flare. Ah, whoops. Yeah, okay. All these steps need to go away. Okay, that's fine, that's fine. You come out 18. You come out 18. There we go. What we want for these panels is for them to extend out to here, so that they're basically like supported by the exterior walls. I'm pretty sure this doesn't work. No. Okay. So repeat what we did earlier. Move that and split that one. Yep. Uh, yeah, I use millimeters because it was just easier to switch over. I tried to work in inches, but most of the people who use my design are not in the US, so I just figured it was easier to switch. Okay, so got this now. We want to extend these out like so. And same for this one. Wait. Okay. I mean, I did that wrong, but I guess it doesn't matter. Okay, split this like that and remove. Cool. So this part's a little bit tricky. I can already tell. Maybe not. It's just getting these pockets cut here. So because this panel kind of intersects at an angle here, Yeah, it's not 90. It's more like 10.8 degrees, or sorry, 79. Um, it could make things a little bit tricky for assembly. I mean, I can just cut that pocket bigger on the CNC, um, but since that's not like a perfect 90, I'm just gonna have to see how all this is gonna fit together to make sure that's actually like doable. Wait, would it be a perfect 90? No, I don't think so. Okay, well, that's fine. Okay, so this panel looks good. Do actually need to split it up here. Cool. Yeah, that's looking actually pretty decent, I feel like. I want to rough out where the ports are going to be. So to do that, it's easiest to make a circle that's going to be your quarter wavelength. And I'm hopeless because I always use this calculator. So we know it's going to have to be 500 hertz, 686. Um, Divide that by 4. Whoa, is that right? That feels like really close. Hang on. You actually see what I did in here. Okay, so for this design, I used a circle with a radius of 343. Oh, yeah, because that's radius, not diameter. Okay, so back to here. That needs to be that. Okay, cool. That's where the center of the ports need to be, roughly. Usually it's easiest to kind of just come out here. Actually, that needs to be that. Sure, we'll put it there. And then whatever the actual like port area for this was is probably what I need to reuse, which is just roughly 3813. So that's kind of my target. Actually, I did something different on these, didn't I? It may actually be way, way easier just to copy this whole sketch because the actual um, like acoustic crossovers aren't going to be anything different with this. There we go. I think, yeah, that's not supposed to move like that. Oh, great. Um, okay. I know I want this parallel with this line, and I don't want that to happen. Yep, that's fine. Sure. Okay, so that's getting there. We can definitely move it out a bit still. Sometimes really don't like working with fusion sketches for this kind of reason. Yeah, there we go. Actually, like, given where that line is, where the throat adapter terminates, kind of wondering if I even need to do like this kind of um, extension part into the actual throat adapter or not. Of course, I think like the logic there is I wanted to get the ports in as close as possible for like maximum summation. So it's a little bit of a balancing act because with the wide coverage top, you have a lot more kind of like a lot um, faster of a flare rate. So by the time the wavefront gets to the taps, they're like a relatively small part of the horn. Um, Whereas with this one being like a 55 by 55 coverage pattern, the horn is going to have much less of a flare rate, um, meaning the taps are going to take up more space. So, I mean, as long as like the middle of them is roughly where that line is, we should get like ideal summation. So I probably can push them out a bit to kind of prevent any interruptions to the compression driver wavefront or mitigate that somewhat. So like maybe something like this. But at that point, it's like, okay, the middle of the port's well outside a quarter wavelength, and we're more like, um, actually, there's an easier way to do this. Okay, that's kind of like the third wavelength, which some people are saying is okay, which it should be. I mean, it still puts the sources like in the summation range, but yeah, maybe it's like worth a shot trying. Yeah, I'm just gonna leave it right there for now and see how it looks. And then the surface area, our target was, uh, hang on, I forgot the number. Need roughly 3,800. I'm gonna write that down. Okay, so we're at 3,500, so we can actually go a bit smaller. I think I'm gonna make this a little bit smaller than. Okay, so now we're at 962. 2080 is right at 3000. So square millimeters, we need to go a little bit larger. Maybe I'll try going to like 38 on this. All right, so got 1100 plus 2177, so 3200. Okay, we're getting there. We should try 40. Okay, that's 1256 and 2287, 3500, just a little bit more. I could bring it down a little bit closer to this edge. Yeah, I don't want to bring it too close because if I bring it in like more closer than 5 mils, that piece is gonna like tear out when the CNC tries to cut it. So maybe we can just like ease that in a bit more, bring this up, see if that gets us there. Yeah, it's like 3700. It's close enough. Yeah, that should actually work. Something a bit like that. Now, on the face reflex port side, um, also like, is that too small? It's like 5 mils. That should be fine. I might go back and change that though, or tweak it a bit. Yeah, so the base reflex ports, normally I like to put them on this panel, like down here, but um, I'm just trying to think about how like this internal kind of chamber is going to work. Because if I put them way down in here, they're like not really a part of the larger enclosure. They're kind of in their own pocket down here. And in a way, this like long, skinny section might act as a resonator in some ways, um, which I don't want, because then it's like some kind of weird horn. So, I mean, I have enough room on this where I could put them like on the same panel. That probably actually wouldn't be a bad idea. I want to like mock that up and see how it looks. And I'll just reuse the same ports I had here. Makes it really easy. Okay, grab that. Actually needs to be mirrored. Okay, can I do that? Apparently I can. Okay. Just kind of realized like it makes more sense for me to just use that same sketch here for this. Like, why would I create a separate one? The size of this port will need to change because the internal volume of this cabinet's different, but I'm not going to worry about that just yet. Just trying to get the placeholders where they need to be. That sketch can go away. Yeah, maybe something a bit like that. It looks pretty weird. I want to see how it actually looks like mirrored though. Okay. Yeah, I mean, it's not like terrible. This thing's going to be pretty heavy though. I'm also curious, like, if I change the parameters now, does everything work like it should? Wow, it actually did. I'm um, I'm surprised. Wonder if this one will. Okay, yeah, that one breaks things. Won't do that then. Do I think it'll be movable alone? Um, maybe. Yeah, I think if I'm able to get these sides made out of 12 millimeter plywood instead of 18, it's probably going to be right at I would say want to say like maybe 85 pounds because the wide coverage version is 75. Oops. And that's 750 by 470. And this one is 800 by 800, I guess. I don't know. That might be getting on the heavier side, but it's also like I could probably get better handle positions on these to where it's at least a little bit um, less awkward to carry. You definitely wouldn't be able to like put it on a stack or on a pole alone. Okay, going back. Yeah, I mean you could put these on a pole if you wanted to do like singles, and you definitely could run them and get the nice 55 by 55 pattern. But one of the things I want to do is really make this for arraying. So to be able to be ran in pairs of two per side to cover like larger crowds, so like 500 to 1,000 people. Because this design, as much as I love it, is meant more for portability. So you won't be able to necessarily cover like the larger crowds with the original JMOD. Anyways, Acrobac finished. Nope. See if it actually made anything. This step usually doesn't take anywhere near this long, so I have a suspicion that it's um, it's not going to give me good results because something's glitched. Yeah, yeah, okay. That's yep, looks cool, but pretty pretty meaningless. Okay, so something is wrong with the model. Um, and I suspect it's the horn part, although I'm not really sure what. I mean, it looks fine. Yeah, I might just come back to this later. Okay, so we're at the ports. I feel good enough with them where they are as like placeholders to leave them. Um, kind of want to look at the rear panel now. Actually, just driver access in general. So there's kind of two ways you can do driver access with a horn like this. One, you can actually have this whole like flare section removable, which I'm not crazy about because it makes the front look not as good. The other way is actually like hatches, which I'll probably do instead. So ideally, the fewer hatches I can get away with, the better. But we need to get both 12s in and the compression driver. Maybe a rear hatch is usable for the compression driver. Yeah, that's definitely important. I'm also kind of looking like if I can do this access hatch on like this big flat panel here, it does make things a bit easier. So maybe like this. Yeah, maybe something like that. Because like at least this allows like pretty easy bolt access, and you'd just be able to lay the cabinet on this flat end and access the driver from the top. Plus like the, I guess, hexagon shape is pretty cool. All right. So let's assume we give that. And then we need an actual like frame in here. Yeah, I might need to think about this a little bit. Okay, so we could do be something a bit like that. Yeah, just kind of like roughing it out. And then probably M6 fasteners holding it there. So assuming I do that, these need to come in like 15, maybe like 18. Sure. Okay. So the access panel is a bit like this. And that should fit the driver through it. But I can actually check since I have a high quality model. So goes in. Oh yeah, that's like too much room. Yeah, I can bring.
As a brand you've trusted for almost 100 years, through the barbecues and the birthdays, so many birthdays, we know a thing about style and dependability, and we know the meals we serve are as important as who
Don't
we
know
share
where
them
that's
with.
coming from.
Hi, we're Chinette.
Ah, a little scary. Okay, so yeah, I can make this access hatch like a good bit smaller. Actually, got an idea. Cool. Yeah, this is why I like Fusion. And like, okay, yeah, this line actually needs to be parallel. Perfect. Um, will the hole screws for the driver be easily reachable for assembly service? Yeah, I mean, yeah, they're much better in this cabinet than they were with the old one. Like you don't need any special tools. Getting into them is like actually pretty easy. So yeah, um, I just use like a hex key set. Takes about 15 minutes to install all the drivers. So same idea with this one. Want to make sure the drivers are easily accessed. Um, yeah, um, I don't remember how to actually return this to its position. Okay, but like in general, kind of like the shape of this. I think I'm going to change just a couple things real quick. Extend that out a bit. What this doesn't give you good access to, though, is the compression driver, because I don't think you could reach your arm through that hole to get back to here very easily. Um, that would just be a pain. Because, like, assuming the 12 isn't installed, you've still got like a whole um, mounting flange that you can't see here, and this would actually be upside down. So maybe look for a better kind of compression driver mounting solution, or not mounting solution, but access. I'm kind of wondering if you could always like slide the driver in sideways and then rotate it in there, which means if I did do like a kind of rear hatch here, I could make it a bit smaller. And what I could even do is for that rear access hatch, mount the speak-ons on it. I don't know if that's like a nice to have so that those are removable, but maybe. All right, let's see what we got. So like, yeah, the hope is that you're not replacing drivers all the time. And if you are, you might need to check your limiters, but it shouldn't be painful to assemble. That's just not fun. As far as like making the whole horn removable, it's just aesthetics. I don't like the look of like the hardware you need, the gaskets you need. There's like an extra lip. I just generally like the look of like this clean termination where you have the horn and then like the exterior walls, and there's like no gap or step or ledge or exposed fasteners. But I mean, the other way of having the horn removable is totally viable. All right, so I'm gonna say like maybe 100. You like 120. Yeah. And then this would get rounded. Sure. And these can probably be M5 bolts since this is a smaller panel. Um, Maybe not. I can experiment with that. That should be enough of a lip to get a gasket seal on. The thing I don't love is that's not a lot to glue onto. But again, it's kind of a small panel, so it might not be a huge issue. So we'll extend that out a bit. Go like 180 maybe. Oops. There we go. Okay. Yeah, something a bit like that. I'm even going to go ahead and model the bolt holes for these. So assuming we have 18 millimeters to work with, 9 millimeters in. Actually, let me just do this. Yeah. Maybe something a bit like that. I do sometimes. It depends on the job. I like the look of exposed T-nuts sometimes, but lately I've been kind of hiding them a bit more. The reason it's not in the plans, like to have recessed T-nuts, is because they come in different sizes. So I don't really know, if people are building them to have like a larger or smaller diameter one. So that's why I don't really make the recesses, but you can change that in the plans pretty easily. Okay, since this is a weird shape, I'm gonna try a different way of making these holes. Um, okay, there's supposed to be a pattern along path option here. I don't know what happened to it. Maybe it goes like this. Okay, it does go like that. There we go. I also just realized these are half circles. That's annoying. Um, hmm, okay. Yeah, see, I thought there was a pattern option in the sketch, but I'm not seeing it. Like, Google might be of help. Oh, there is no pattern on path for sketches. Okay, so there's just not. All right, that's fine. I'll just make the whole panel. I like to save like mirroring until the later steps just because it makes everything easier if you just model like a half or a quarter of the thing and then just mirror it later. But sometimes you just have parts you can't avoid like this. I don't need that anymore. So we'll go out 9 millimeters again. Oh, I'm gonna need to mirror that part too. There we go. Okay. Um, the model for the DCX I made just because I got tired of not having it. The model for the 12 NDL88 is from BNC, and that's why it's such a nice model. Okay, so path direction. Probably like 12 of these. And then can't remember how you actually get these even. There is a way to do it. Yeah, it's definitely like fun just to kind of build models like that. I have one of my neighbors has like a really nice 3D scanner, so I'll take that sometimes and scan like the more rare or interesting drivers. So I just have 3D models of those too. All right, maybe I can go. So that definitely needs to be 12, but oh, maybe that's how you do it. Okay, Now they're actually even. So 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Okay, now that's 12. That hurt my brain a little bit, but I think that's how it should be. Yeah, okay, that looks right. And somehow this messed up. Or no, I just had something hidden that shouldn't have been. Okay. Trying to think what next would be important check. Probably the rebates is a good thing to start kind of looking at, seeing how bad it is, because I have no idea how this is going to work. Actually, okay, I just wasn't thinking about it right, because apparently that is a 90-degree rebate. For whatever reason, I thought it was that panel would have to fit in it at an angle, but that doesn't actually look to be the case, which is great. Okay. Um, so for dog bones, I know some people do that in the cam part. I know some people have a plugin that does it. I just make a sketch for it, honestly. Um, I think I don't know if there's like a right way to do it, but that's the way I've found is just fastest for me. Okay, so for this part, I want to do that. And then same for this. So this panel is a little bit funky. If you look in the new JMOD plan, it's the same here, where basically you have this little lip here, and what that means is like, okay, you can't cut this on a table saw, so the CNC has to cut this like bevel, but it means that these inner flares can have just very simple 90-degree edges there and there, which just makes things simpler. So it's a little bit of a trade-off, but I think it's worth it because the CNC can cut that no problem. Okay. So for this, bring that out about 30. Maybe more like 50. Yeah. And we cut into the bottom part here. Cool. And we'll do the same for this. Oh. Okay. Sure. Just pretend that didn't happen. Cool. Okay. This is like the part where it starts to get a little bit confusing, but I think it's starting to come together. Okay, somehow we have a duplicate body here. Okay, guess I can remove that. All right. Um, that looks good. That could be like an annoying crevice there. Um, it also might be just something where I put filler in because that's like what, 5 millimeters across. Hmm. Actually, what am I talking about? I can just do this. Uh, there we go. Okay, so this panel comes down 5 and cuts into the rear panel. Oh, yeah, no, that's not quite it. Okay, I'm just going to use a sketch. And before I get any further, I'm going to go ahead and add in my V-bait, or just call it glue gap, which is 0.6 on my CNC. And there we go. And I think we can just pull that down 5. Yeah. Yeah, so the glue gap is um, just to help the pieces fit together. So like technically I buy 12 millimeter or half-inch plywood, but it can come in a little thick. Actually, it usually comes in a little thick. So I'm not sure if that's something where maybe the CNC cuts things too wide or too narrow. But either way, you want a little bit of like play for the actual uh, panels to slide it into, because if that's a zero tolerance, they won't fit. And then like you said too, like the glue can fill in that gap there. Okay. So now I can actually go back to isolating this and fix these rebates. Okay. When I add dog bones, I usually just create like a circle sketch and then drag it up to the corner where it needs to be. And then for this part, it's just going to be easier to kind of bridge that. Whoops. And I think that's it. Okay. I'm gonna actually label these now because I'm forgetting what's what. So this will be, I'm looking at it from the top. Yep, okay. Oh, okay. Don't know what that body is. Gonna remove it. Okay, somehow that's another duplicate. Okay. And that should be it. So I'm trying to think of like what kind of bracing would be needed. So I'm just going to go ahead and like mirror the full model then, and then kind of figure out what might be weak points in the model. Also, I think what would look really cool is maybe having if the base reflex ports are going to be on the same panel as the bandpass ports, like the actual shape matching. Because even though these are going to be a little bit smaller, it might look at least visually appealing to have them like the same general shape. I don't think the shape matters too much, to be honest. Like I used to think it mattered a lot more, but in like the larger style mez like this, as long as it's round-ish, it's usually fine. It's not for stuff until you like start to do the smaller stuff like the Solana where it gets a little bit more important, I think. So we can make some artistic decisions there. Okay, so actually I need the area from that. 2000. Oh, that broke everything. How did that happen? Okay, yeah, I need like better sketch objects than this because this is like a pain. Here we go. Wow. Okay, here we go. Where was that extrude? Cool. All right. Something a bit like that. Now, I think now that I have the actual like full model, I can kind of see now where there might be some structural issues. Mainly that like the whole horn is suspended and relying on just that where the mouth terminates to hold it to the enclosure. So it definitely needs something like, although I guess it is in these side panels here, so it's not quite as bad as it looks. So it is rebated there. But I almost wonder if like there should maybe be like some kind of arches here or like some kind of frame. Um, yeah, kind of have an idea on that. Okay, so basically come in here about, yeah, 125 or so. And then maybe kind of, actually, this is like a very rough sketch just to see if this idea actually works. And that's not solid for some reason. Ah, there we go. Yeah, almost something like that. So I'm gonna hide this panel again. Yeah, because that way there's not like just this giant swath of a panel that doesn't have anything holding it in place. And I may even like extend this up a bit. Yep. And then even uh, bring it in a little bit too. 'Cause generally having a large panel that doesn't have like any breaks or um, anything connected to it will start to resonate. So this way we're adding a little bit more ribbing, a little bit more support. And then because these are kind of U-shaped, they should be able to get cut pretty efficiently. They won't use up a ton of space on the CNC. But I think I'm gonna leave it there. Um, I don't want to get too far into designing this tonight, just because there's a lot of work to be done solely in the ACABAC and simulation part. Um, Main thing is I just wanted to figure out like mechanically how it would all kind of fit together and work. And I feel like the solution's pretty good. I don't think there's anything that's like that kind of jumps out at me as being like scary to assemble or kind of like put together. The axis panels are super easy to cut. They're not there's not like any weird geometry with those. So um, yeah, feel pretty good about where this is headed. Very, very, very different design than any of the other ones I've come out with yet.